All right, so this first part basically is how a GCS works. What the ground control system is doing is providing an interface between the aircraft and the operator. There are three main components that are going to make that happen. We have hardware and firmware. So this is the machine human interface. So I have to physically put my hands on something, and that something is the ground control system. Basically, in the context of this first slide, what I'm talking about here is the hardware and the firmware. This is the ground control system for 3DR Solo, basically comprised of this hardware device. Allows me to do some stick wiggling here. And then there's also, so this is basically the hardware and the firmware. And the definition of firmware really, firmware just tells hardware how to interpret the information that's coming into it. So firmware is really tied to the hardware. So it says, like, you know, when I push the left stick up, that means that I'm going to accelerate. The UAS is going to climb. So the firmware can be adjusted to say, like, when I push the left stick up, maybe the aircraft is going to go down if that was, or descend, if that's something I desire to do. So we have hardware and firmware. And then software, what we're talking about is I have my iPad here as part of the 3-year Solo ground control system. On my iPad is the 3DR Solo app. So that's really the software. So the app is really interpreting the information that's coming to the GCS. So the GCS has some computers on board. That's part of the hardware that's making some analysis, while the software decides how does that analysis look to me? What am I going to see when I look on the screen? All right, so hardware, software, application, and then the operator. The operator is a part of the ground control system. And I know an operator is also part of the UAS. It's part of one of those four broader components of the UAS, but the operator is also an important element of the ground control system. The three-way communication of the GCS has to have an operator involved in all those actions. The three components that I'm describing all act independently. The hardware and the firmware, so my 3DR Solo controller is the blue circle. It is independent. It isn't attached to the software. The software on my iPad is independent of the hardware. It exists in its own space. I exist in my own space. But those three things also come together, and what happens when myself, the software, and the hardware come together is all of a sudden I have the ability to control the aircraft. And that basically is how a ground control system works. The most important differentiation of information within a ground control system are command and control, also referred to as C2, and some sort of video communications, right? So typically we have some sort of onboard visual sensor on a UAS, and whatever information we're getting from that sensor, whether it's video or still photos, or you could even have some other type of sensor that isn't a visual sensor, maybe it's collecting real-time temperature data or whatever. Typically that information is transmitted over a separate video stream. So you have a separate radar, or excuse me, separate radio, separate antenna, separate communication stream that's going to send that visual information as opposed to C2. So what is command and control? What is the command and control process? Command and control is what tells the aircraft to move. Okay, so command and control gives you information, so it communicates with those onboard components that we talked about last week, the flight controller, the autopilot, the computers that are analyzing the onboard diagnostics. So that all that information is essential for command and control, because the other side of command and control is that as an operator, we are looking at the current location, the current aircraft settings, and we're making some decision about how is the current, what is the current status compared to what the status that I want the aircraft to be in, right? So if the aircraft is here and I want the aircraft to be over here, what do I have to do to make the aircraft move from point A to point B? It's the command and control. The C2 is what is going to provide the information that tells the aircraft to move over to that location. So this little diagram in the bottom really spells it all out. And what the big thing I want to point out is the ground control station, or excuse me, the ground control system is at the center of the UAS, right? And the 3DR Solo GCS actually is a great, has this great example, because it's a great platform to teach UAS operations on, because this ground control station, unlike DJI, which uses a wired connection, the 3DR connection is actually a Wi-Fi connection. So the ground control station actually represents a Wi-Fi hotspot. Okay, so that Wi-Fi hotspot connects to the tablet, and so you can sort of think of it as, so the tablet is what is the interface for me. So the operator is communicating with the system through the tablet, which is connected to the Wi-Fi hotspot. Then the aircraft is connected through our antenna in the ground control station, which also provides information to the tablet through the Wi-Fi hotspot. So the ground control station becomes that central hub, the central hub of communications between the operator and the aircraft, right? And then, so command and control exists in two forms, right? So that communication is going from the GCS out to the aircraft. It's also going from, and that's through the radio, right? So our one of our radio antenna, and this isn't exactly how it works, because the way I think it actually works, I'm not 100% sure, but I believe one of these antennas is for C2, and then one of these antennas is for our video link, okay? But so if we said the C2, our command and control, is the left antenna, then this left antenna is both sending and receiving information on command and control, where command and control is coming to me and being transmitted from me through the GCS, through the ground control system itself. All right, so we have radios doing the communication with the aircraft, but we have the human-machine interface doing the communications with the operator, right? So the human-machine interface in this example really is represented by, I'm going to stop sharing my screen so you can get a little bit better picture of the ground control system, the Solo ground control system. But so the human-machine interface represents my stick so I can give manual inputs to the aircraft. These buttons so I can select what fly mode I want to use. I can turn the ground control system on and off. You can see the little window right there. There's actually a little display window on this ground control system. If I was connected to an aircraft, what we would see is a bunch of diagnostic information, battery level, connection status, other information in my little window here. And then the iPad becomes also part of the HMI, where I'm actually seeing my video stream. I'm getting a duplicate of some of the information that's on the hand controller itself on the iPad. But these other buttons allow the human to also control the aircraft in other ways. So we have the human machine interface, which allows me to talk to the GCS, send information to the aircraft. And then we have radio communication here represented in the back of the GCS, which communicates that information to the aircraft and then takes that information from the aircraft, communicates it to me through the human machine interface.